Okay, I think this should be working. So I just wanted to go over, um, while I make the answer key, just go over the um, solutions, just in case that would be helpful for anyone. So let's do this. I'm just sharpening my pencil. Okay. So these are actually kind of like my steps. Like, it's literally like step 1, step 2, and step 3. So there's not necessarily a greatest common factor here, but when I look at here, I'll just see if I should. So when I look at this one, to factor by inspection, I need the coefficient of the x squared term to be +1, which is exactly what is kind of like stated up here. So in any case like this, I need to factor out -1. So that's what I need to do here. Well, I'll show the dividing part. -x² dividing each term by 1. Sorry, -1. So gonna kind of run out of space, but I might not need to use so much space in other places. So -1, negative divided by negative is gonna be positive. Positive divided by negative is gonna be negative. Negative divided by negative is positive. So you can also kind of think about it like we just changed the signs. When we factored out a -1, this term became positive, this term became negative, and this term became positive. Okay, finally, now we are actually in a place where we can factor by inspection. So I want, kind of running out of space, I want 2 integers which multiply to +16 and add to -10. Because that's always the thing. I'm always looking for 2 integers which which multiply to my C and add to my B. So, well, you know what? It's gonna be x minus 2, x minus 8, because just for the sake of explanation, I'll just pull over a different piece of paper here. So it's like 16, we can get to 16. We can get there by having 1 times 16, 2 times 8, 3 times nothing, because 3 doesn't work perfectly like that. 4 times 4, that's it. So I know that like to get to positive 16, to multiply to positive 16, my integers need to both be positive or both be negative. Because positive times positive is positive, and negative times negative is positive. So basically, I know it has to be -2 and -8, because those actually multiply to positive 16, and they also add to -10. There's no other way with these combinations. There's no other way of having them both be positive, both be negative, and having it work out. So that kind of goes along with that problem. Okay, let's move on to this one. I'm just gonna kind of block this off. So here's a problem. It doesn't look exactly like that trinomial that I want. So that tells me I definitely have to factor out a greatest common factor. Just for the sake of like breaking things down a little bit, 5 is already prime, so I can't break it down anymore. 55, 5, and 11, these are my prime factors. 120, 2 times 60, 2 times 30, 2 times 15, 3 times 5. So let me just, I'm kind of trying to write out all my factors right now. So 5x squared b minus 55bx and 120b. Well, I know that this one is 5 times x times x times b. This one is -1, because when I see a negative, I need to have that factor of -1 in there, times 5 times 11 times b times x. Just gonna make sure it looks legible. This is gonna be 2 times 2 times 2 times 3 times 5 times b. 8 times 3. Yeah. Okay. So what's common? I'm looking for my greatest common factor. Well, they all have a 5. They all have a factor of 5. They also all have a factor of b. So my GCF is 5b. So I basically want to pull out that 5b. And I'll show myself dividing each term by 5b just for the sake of illustrating exactly what's going on. It's like brain is buffering right now. 120 divided by 5, 24. Okay, so I did my step 1. I factored out the greatest common factor because I could. Now I have a trinomial which meets my requirement of having this coefficient be +1. So I'm factoring by inspection. I need those two integers. They need to, just get a different piece of paper. These two integers need to, multiply to positive 24 and add to negative 11. Okay. 24 can be 1 times 24, can be 2 times 12, 3 times 8, 4 times 6, 5 times nothing, and I don't need to say 6 times 4 because then I'd be repeating myself, and it would keep repeating myself. So basically, like, you don't have to list these out every time. I'm just trying to, like, really illustrate. So, okay. Just by looking at it, I know there's no combination of these ones that can get me to negative 11. But I know that 3 plus 8 is 11. So positive 3, oh wait, no, it's not going to be positive 3. It's going to be negative 3 times negative 8 equals positive 24. But negative 3 plus negative 8 also equals negative 11. So that works. Negative 3, negative 8. Okay. Here we can basically, it's like this light is a little weird. That's fine. So I don't have my little trinomial that I want. I want the coefficient to be positive 1. I know I need to factor out a greatest common factor here. I'm just going to show my little factor trees again. 3 is prime, so we're good. 15 is 3 times 5. 42, 6 times 7. 7 is prime. 2 times 3. Okay. So let me take all these little guys. So for negative 3x squared, I have that factor of negative 1 because I need that factor of negative 1. Yeah, to make it negative, just like before. Times x times, oh, forgot my factor of 3. Times 3 times x times x. 15x. I'm basically taking these prime factors, 3 times 5 times x. 42 is 2 times 3 times 7. So now I'm basically wondering what's common. Well, I can actually see there is a 3 that's common. So why don't I'll just factor out my 3. Okay, so just showing that division so that we are still clear on what's going on. Okay. Only issue, we are running into the exact same issue as before, where there's a negative 1 coefficient on that x squared term. To factor by inspection, I need the coefficient of the x squared term to be positive 1. Factor out negative 1, so I'm going to do the exact same thing. And again, I'm showing a lot of work here for clarity. You wouldn't necessarily need to show all of these steps. You could factor out a negative 3 all in one go, because that's kind of what your brain might do. If you look at this, oh, well, I definitely need to factor out a -3 so that that thing becomes positive. My sign's flipped, so I'm good. I'm good to go. So I need two numbers that multiply to -14 and add to -5. Well, 14 can be 1 times 14 or 2 times 7. That's it. Well, looks like 2 and 7 can be a good combination because how can I make that work? +2 plus -7 equals -5, but +2 times -7 equals -14. Okay. Oh, just broke my pencil. Okay. So, +2, -7. Okay, cool. I'll try to actually box in my final answers just so that it's not so chaotic. Okay, finally we're getting somewhere. Okay, this one is just perfect already. It doesn't, nothing has to happen. There's no greatest common factor. It's already what we want with that +1 coefficient. So it's just what are two numbers that add, multiply to +30 and add to +11? Well, 30 can be 1 times 30, can be 2 times 15, can be 3 times 10, can be 4 times, that doesn't work, 5 times 6. Look at that. I know that's going to work because +5 plus +6 is +11. But at the same time, +5 times +6 is +30. So x plus 5, x plus 6. All right. Okay, so the thing that should ping off for me is, oh, these are both binomials. So it looks like I'm in difference of square territory. So let's just get the, it definitely looks like I need to take out some kind of greatest common factor. 810 can be 2 times 405. This is 5 times 405 divided by 5 is 81, 993333. So 810 equals I'm just going to double check. 2 times 3 times 3 times 3 times 3 times 5. Good. So 160 280 8 times 10 2 times 4 2 times 2 2 times 5. Okay, so it's gonna be like 2 2 2 2 2 5 2s 1 2 3 4 5 and 1 5. Cool. And then I also have my little k's in there. So what would be my greatest common factor? Well, there's a factor of 5. There's a factor of 2. That's it. Oh. Oh, weird. Okay, so, hopefully I'm still recording. I think I am. So, um, GCF is 10. And remember, the whole point with difference of squares is I want to have something squared minus something squared. That's great because I can actually already tell 81 is 9 squared minus 16k squared is 4k squared. So that's my A, that's my B. So it needs to be 9 plus 4k, 9 minus 4k. And that should work out. That would work out. Same thing over here. Let's just get our little greatest common factor just for the sake of doing it totally like just clearly for whoever may watch this. Okay, so 363k squared equals 3 times 11 times 11 times k times k. 27y squared is 3 times 3 times 3 times y times y. The only thing that's common is the factor of 3. I guess it's going to be 121k squared minus 9y squared. I know I can write that as 11k squared minus 3y squared. So that's a squared minus b squared equals 11k plus 3y, 11k minus 3y. Just make those ones look very clear, hopefully. And that should be that. So, yeah, cool. I'm gonna stop the video here just because I want to make sure it's all working still. Okay, so this side was actually, maybe it was a bit more challenging for some folks. I have no idea. Like, it's just kind of like, it was a bit of like a cumulative part. Like, it covered things that had been sort of assessed in the past. And so that might have been confusing for some of us, which is especially why I want to like go over this part. And I'll try to show it. Oh, is this pen ever going to sharpen? I'll try to show it, or pencil. Okay, this pencil's crazy. I don't think it's gonna work right now. That's fine. Okay, so I'll try to show it like the way that I didn't really ever show too much when we were actually going through this. But we basically can have x plus 12, x minus 7. So we can basically multiply this way. Oh, whoopsies, I'm messing up. Negative 84. So that's actually like the same as if we did FOIL. First is x squared. Outside would be negative 7x. Inside plus 12x. And last would be negative 84. See how we get the exact same terms? And then we combine like terms. And that's it. That's all I want to do in this question. Okay, so this, just remember, it's actually negative 2 minus 4b times negative 2 minus 4b times negative 2 minus 4b. So you can't multiply all of these at once. You have to like take two of them and kind of go step by step. So let's do this again with our little box. Just because I think it's a good way of showing what's going on, and I think it may help some people, hopefully. It's just, it feels a bit more organized. Positive 4, positive 8b, positive 8b, positive 16b squared. So if I had to like write that out, that would be like 16b squared plus 16b plus 4. And that is now what I'm multiplying by negative 2 minus 4b. So I'm just kind of double checking. If I were to FOIL, would it have been the same thing? Just because I'm a little bit more used to FOILing. 4 plus 8b plus 8b plus 16b squared. Yeah, it would have technically worked out the same way. Okay, now I want to multiply this by this last thing, because we already did this, but I have to take this result and multiply by that again. So it's basically this. So let me draw my little thing again. So is that enough slots? Oh yeah, it is. Negative 2, negative 4b times 16b squared, and that's positive. Positive 16b and positive 4. So negative 32b squared. Oh, this is going to be crazy. It's not that crazy. Just have to do some multiplication. Negative 64b cubed, negative 32b, negative 64b squared, negative 8. This question's like pretty laborious, not gonna lie. Minus 16b. So I'm just gonna double check, did I do everything properly? So this is negative 32, because that was negative 2 times 16, negative 32, b squared. Negative 64b cubed makes sense. Negative 64b squared makes sense. Negative 32b, negative 8, negative 16b. So it's like, can I combine like terms? Well, so I guess I'll just write out everything. So I got this, just kind of lightly cross it out. Minus 32b squared. Kind of going in descending order right now, just so it's easier to organize later. Okay, so that's looking crazy. I'm gonna have to take some space here. Negative 64b cubed minus 96b squared minus 48b minus 8. Whoa. That was a hefty little problem. I kind of just want to like Wolfram Alpha to just see, am I on the right track? I just don't want to like create the whole video and then have something messed up inside there. Cool, that's actually correct. Okay, so I don't need the pen right now. Okay, so, okay, see, these are like really like laborious, not gonna lie. So here, I'm looking at this. I need to think about bed mass, to be honest. So if I focus on bed mass, I know I want to deal with this exponent first. X minus 7 squared equals x minus 7 times x minus 7. Let's just draw our little box. X minus 7 times x minus 7. X squared minus 7x minus 7x plus 49. So that's going to be x squared minus 14x, because I combined like terms, plus 49. Okay, so I have this thing. It's not actually my final answer, so I don't want to like box it in. But basically I have that thing. I'm trying to take away the result of this. And that would be my next thing to do if I'm going through bed mass, because I already dealt with my little exponent. So now I want to do the multiplication. So let me do my little box thing. It's getting a little crowded. This could have used more space, that's for sure. That's my own fault. 8x squared x minus 48x and negative 6. So cool. So that would be, this one would be, maybe I'll just kind of box it in like that. This one would be 8x squared minus 47x. I just combined the like terms, minus 6. So basically, all in all, I have this thing which is, I have x squared minus 14x plus 49 minus 8x squared minus 47x minus 6. And then I do my little step where I get rid of the brackets. Minus, take away a negative is plus. Take away a negative is plus. And then I combine like terms. Well, I have started with positive 1x squared. I take away 8. That means I have negative 7x squared. Negative 14x plus 47. Negative 14 plus 47. Positive 33x. Plus 55. 49 plus 6. Let's just see, are we all good? Because again, these are very labor intensive, and I just don't want to get too far off track, especially when this is a video. Okay, perfect. That's correct. So, okay, this one, let's just do this one because this one's, let's just do this one because this one's super chill. 2a plus 2b plus 3c. It's like a regular old distributive property. Nice. Well, all of this is distributive property, but this is like day one, you know what I mean? 2a squared plus 4ab plus 6ac. We could have done that with our little, box thing. A, 2b, 3c. Two a times a is 2a squared. 2a times 2b is 4ab. 2a times 3c is 6ac. So it works out either way. It was kind of redundant to actually show that, but that's fine. So this is getting crazy. So I'm gonna like block off some sections. Because this also looks absolutely bonkers. So let me just write it out again, because it's too complicated to see it amongst all those other things. So yeah, this is like pretty intense, not gonna lie. So there's a lot of steps. Okay, well, let's just start. We can just start by multiplying these things. So it's honestly a little bit, it might take a little bit longer to do it with this box way. And it's not necessarily better, but you should use whichever way kind of makes sense for you. So that became 12x squared plus 8x. And we want to times that by x plus 2, because we found the result of this times this, the product, but we still have to multiply that by this. So to be honest, I kind of just want to use regular FOIL just to like save space. Okay. okay? That's actually, so that's kind of all of this together is this part. I want to subtract this, but since I follow BEDMAS always, I'm not gonna think about this negative until I've done the multiplication. I don't think about addition and subtraction. In BEDMAS, I don't think about addition and subtraction until I'm done my division and multiplication, so I have to do this multiplication first. X squared minus 6x plus 3x minus 18. X squared minus, squared minus 3x. Minus 18. So that's what I want to subtract from this. So 12x cubed plus 24x squared plus 8x squared plus 16x minus x squared minus 3x minus 18. Do my step where I get rid of my brackets. 12x cubed plus 24x squared plus 8x squared plus 16x minus x squared plus, because negative, taking away a negative is plus. Combine like terms. There's no other x cubed. Okay. Okay, so 24 plus 8 is 32. Take away 1 is 31x squared. Plus 19x. Plus 18. That should be correct. We can check though. So what is it? It's 4x, 3x plus 2, x plus 2. Oh, and then sorry, there's a bunch of minus stuff. Minus. I really hope that's just right. It's like, it's just, yes. Okay, good. Okay, so, okay, that was so much work. This is hopefully gonna be more chill. So this is kind of like a combination of both things. I want to combine like terms, and then I want to see if I can factor. So whenever I see this, I need to do my first step of just getting rid of those brackets. Taking away a negative is positive. Taking away a negative is positive. Taking away a positive is subtracting. How can I combine like terms? I have 3x squared minus 3x minus 330. I can tell from looking at this that I can factor out a greatest common factor of 3. Okay, how can I get something that multiplies to negative 110 and adds to negative x? Well, 110 can be 1 times 110, could be 2 times 55. Don't think it can be 3 times anything. No. 110. Nope, not by 4. 110 divided by 5. 5 times 22. 110 divided by 6. No. 110 divided by 7. No. Not by 8. Not by 9. Okay, so yeah, my video did something really weird. But basically I was saying that 10 and 11 would also multiply to 110, and I could see how negative 11 plus 10 is negative 1, and negative 11 times 10 would be negative 110. So that actually works for me. Basically, we'd be able to 3x, x, negative 11, positive 10. That would work. Here, it says, if necessary, expand. So I can see I actually have to do some expanding here. So negative 75n squared plus 18y squared. Taking away a negative is adding. So basically, now I can combine like terms. Negative 50n squared plus 18y squared. Well, how does this help me? Well, I want something that looks like a squared minus b squared. So I can just change the order. It's still 18y squared, positive 18y squared, minus 50n squared. So I didn't change the sign of anything, which is totally fine. And that'll work. So it looks like I can factor out a greatest common factor of 2. To 3y squared minus 5n squared. So it's going to be 2, 3y plus 5n, 3y minus 5n. Okay, so that's pretty much that. I can't show this right now because I'm not sharing my screen, but why don't I just make sure that it's correct. Bear with me for one moment. Yeah, it looks correct. Perfect. Yeah. Okay, so that's that. That's that.